Okay, microphone's on, awesome. Wow, I'm amazed to see so many of you here, as I'm the last thing standing between you and a cold beverage or the Linux Australia AGM, depending on what you're up to this evening. I updated the time frame on this shortly before coming here, which is kind of really scary. It makes me feel incredibly old. But hopefully you'll get the context of the journey as we walk through this this afternoon. So we're going to do a little bit of history and a couple of technology overviews. Some of that I'm going to skip through quite quickly for the purposes of time, but I've included those slides just for completeness. And then we're going to get into a few war stories where the names have been obfuscated to protect the innocent. And what I'm going to try and leave you with are a few tips and tricks, a couple of things that you can use in your day job, a couple of questions that you can ask your various project managers and project leads and customers to try and avoid some of the missteps I've hit or my customers have hit or I've seen in projects over the years. So, as I said, I stepped back and tried to decide where to begin with this. Where does my journey with digital data begin? And it begins with, if my clicker works, the humble cassette tape. How many others here started their journey in computing with the humble cassette tape? You know, I started computing with the ZX81 and then moved on to a Sinclair Spectrum. So most of my early digital data existed on one of these things, which seems kind of a bit of an anachronism these days. But surprisingly, tape is still quite popular in the enterprise. But where do we as humans start? There's an incredible pool of data through artifacts that have outlasted millennia, things like cave paintings or hieroglyphics, although both of these have suffered data loss and bit rot over the years. Along the way, we've seen the various generations of disk devices, and it's hard to believe the sheer amount of storage we can now fit on a modern hard drive compared with those legacy devices. Which leads into some of the technologies that we use to talk to these devices. And a couple I want to point out are the ones that we would consider legacy today that were prevalent 10, 15 years ago, things like SCSI and IDE, which we don't see in the enterprise so much anymore, at least in terms of an interconnect. At the true enterprise level, we're starting to see wide adoption of PCI-based protocols, but they're filtered into consumer and prosumer devices. For example, my laptop here has an NVMe device that is capable of around 3,000 megabytes a second. Whereas back when I gave a presentation at LCA in 2010 around going mad with MDADM and some of my earlier adventures with storage, I had a hard drive that was capable of about 100 megabytes a second. And shortly through the talk, it started to produce approximately 0.1 megabytes a second as I suffered hardware failure whilst presenting about RAID. So hopefully I'm going to have better luck with the flash device in my laptop today. Data protection techniques, I mentioned RAID already. There really should be more laptops available with RAID. We're going to dig into some of these a little bit deeper later, but again, these slides are here for completeness. And I've also thrown these in because, you know, within organizations, there's sometimes you need to make it clear what the differences is between things like SAN versus NAS. Often the project teams, the project owners and developers just don't care. And particularly today, in modern environments, many of your development teams don't care because all they're interested in is cloud. All they're interested in is object. The cool kids deal with objects. You know, the adoption of S3 type protocols and Swift has become massive inside development teams today. And then we have the various data protection techniques that we all rely upon for providing business continuity. RAID has been dominant for so many years in the data center, and today it's still extremely common to see our enterprise servers deployed with RAID 1 storage just for the base operating system, whilst the rest of the environment may still be coming off SAN or using RAID 5 or RAID 6. In scale-out storage or hyperscale storage, we're seeing a shift towards technology like erasure coding. And immediately when I talk about erasure coding with a new project team, they start thinking about, is this all about data deletion because of the use of the word erasure? Well, it's really about data protection techniques. We move away from RAID. So often I initially describe it as RAID on steroids. You know, in erasure-coded 4+2, we can allow for 2 disks to fail. We've got a 6-disk array. It's kind of similar in a way to kind of a RAID 6 implementation, except it isn't. Under the hood, the algorithms used to deploy this are quite different. With 8+3, we can suffer a 3-disk failure. We're defining an environment designed to suffer failure. But what's really nice about erasure coding is it isn't just about data in the chassis. You can erasure code cross-chassis across the data center, which allows for a higher degree of resiliency and redundancy. And the really neat thing is you can scale +1. I might start with 8+3 and 11 chassis or 11 disks, and then scale to 12 to 13 to 14, and rebalance that erasure-coded array. I'm still running an 8+3 model, but I'm now running it across 16 disks. There's some incredible flexibility around the erasure-coded approach. Come on. Compression and deduplication are very hot topics in the enterprise as well. You know, we've got all those gazillions of cat pictures that can be compressed down or deduplicated down to a much smaller data set. And then we've got the various vendors that various terms your storage vendors will talk to you in terms of, you know, how much raw storage versus effective storage. And this becomes really critical whether we talk about either, you know, decimal gigabytes or true gigabytes. Because what is the actual representation of your storage? What is it really worth? And sometimes you can get really tied up in knots when you actually get this up to superscale and someone starts discovering they're missing several hundreds of terabytes of data because they're using the wrong model to calculate their available disk capacity. So we're going to start with a few of the war stories. So first of all, can I fix this for you? So as I said, 35 years ago, my journey started with the humble cassette tape. And in order to fix most of my early data problems, I had to use a pencil. You know, this is a fairly familiar meme on the internet, and if this doesn't make sense to you, come and buy me a drink later and I'll dig into greater detail. But for those of us even with the humble mixtape that you wanted to save, but more importantly, it was that program I'd spent 4 hours typing in out of a computer magazine, or in later years, the code I was writing myself. In fact, for those days, my backup mechanism was a twin cassette deck to make an immediate copy of my, you know, important computer programs. But what I want to drive home is how important it is to be aware of aging and legacy storage, be it floppy disks, hard drives, optical devices, flash drives, or tape devices. You know, bit rot can occur on a wide range of these. Do any of you remember the phase where there was a massive amount of bit rot on optical disks, particularly printed audio CDs? You know, Philips and Phonograms spent an incredible amount of money replacing CDs that were assumed to last for 100 years and were actually rusting within 2 to 3 years. I've seen a lot of flash device failure, particularly USB type keys, be it either physical failure because people misusing them or just the flash device goes. Mold is a really big problem with your tape devices and on your old school legacy floppy disks. And then you've got all these old interfaces, which can really hurt you if you no longer have an IDE adapter to read that old IDE backup that you happen to have lying around. And then, of course, there's the legacy file systems that you can no longer read or are really hard because they've gone and removed support from the Linux kernel. So a few data recovery tips. Isopropyl alcohol and lint-free cloths are really useful if you're going through a big stack of CDs trying to recover data, because nothing worse than suddenly discovering your CD drive or your DVD drive, your Blu-ray drive no longer works because all the innards are clogged up. I like using USB-based dongles, DVDs, CD drives, floppy drives, ID and SATA adapters, because that way I can hot swap devices on and off. And then I'd like to use something like a NAS, a SAN, or a large USB external drive for initial archive. I'll go into that a little bit more detail later. Tools, things like System Rescue CD, Ultimate Boot CD, DD Rescue's awesome. LZOP or similar tools that are capable of really fast data compression, minimal overhead, some big benefits. The moment you start throwing a big disk image, you know, terabytes of data at gzip or bzip or similar tools, you're just going to burn CPU and time. LCA, test disk and photo rec are awesome for getting really deep and dirty for data recovery. A local author based in Auckland a few years ago reached out to me through a friend because her hard drive had failed with her latest manuscript. 9 months of work. Turns out her backups weren't working because she'd never tested her backup recovery was working. So thanks to those tools, we managed to get every single character of a manuscript back, and she was back up and running within a week. Right? So some of these tools are truly awesome at data recovery. So when the original media has failed, USB dongles sometimes don't cut it, particularly when you've got a really badly behaved ID or SATA drive that's just clunking away, and you're desperately trying to get the data off. So you may need to go and borrow some old hardware. I recommend having some live OS images at that point when you're doing data recovery. I actually have a small USB key that's capable of booting on both UEFI and BIOS-based hardware with a whole range of data recovery tools that I use regularly. And as I said earlier, always create a full copy of the original media. DD Rescue is great, whether it's a flash device or spinning disk, because it will go backwards and forwards and isolate problem bits within the disk that you can't recover. Then use your recovered image or a snapshot of that recovered image to do the next phase of your data recovery and park that disk or flash device out of the way. Because if you just keep using it, it's going to deteriorate even more. I've, on one occasion, had a disk where every time we ran DD Rescue, we got approximately 2 or 3% less data recovery on each iteration as the disk just progressively failed. Come on. And this is one area where hard drives trump flash devices. Technologies like trim and discard are really important on flash SSD or NVMe devices in order to provide wear leveling and improve the longevity of the device. But it means that when you do a delete, it's effectively a true delete. The data is really hard to recover at that point unless you've got very specialized tooling that can get inside the firmware. Whereas when you're doing it on a traditional hard drive and you accidentally delete some data, as long as you can pull the mains really quickly and you haven't started writing new data, you can actually go and use tools like photo rec, etc., to go and probe the disk and find those missing data files. Come on. My clicker's not happy. Always remember RAID is not a backup mechanism. And there's many ways of implementing RAID. You know, the proprietary or in-kernel drivers for the hardware RAID controllers. We're less prevalent now with things like the fake RAID devices. I talked a bit about that in Wellington in 2010. And things like MDADM, LVM-based RAID, ZFS RAID, BTRFS RAID. How many different software RAID implementations do we actually need? But there's plenty of options out there. So back in 2010, I did a talk going mad with MDADM. I was trying to pinpoint an issue around RAID failure, a software RAID failure. And in the end, it was an issue, a conflict between the HBA or the RAID adapter and the chipset on the PCI bus. And we were actually seeing data loss or data corruption, bits being flipped on the PCI bus. In this case, if it had actually been running XFS as the file system, I'd have detected it sooner, because XFS has checksumming, and it would have notified me there was some consistency issues with the file system. Instead, it was ext3 at the time, and in the end, I resolved it by just simply moving everything to a different motherboard. It was a painful thing to diagnose. Since then, I've had other adventures with RAID controllers. So in this case, we had a hardware RAID controller failure where we had no spare compatible hardware. It was the only version of that hardware we actually had inside the organization. So we're starting to look at TradeMe and eBay to try and get a controller that we could actually try and recover the data. What happened was, while we were doing that, we got an old Linux box, put a just straight HBA, no RAID controller, plugged the disks in, Linux booted, discovered the RAID metadata, reassembled the RAID array, thanks to DMRAID, and we were able to back up the data onto some new hardware and move on. So the capabilities in the Linux kernel sometimes just outstanding, amazing, and saved my life. Part 3, a failed RAID 5 array. Now, if any of you have any of these particular Marvel PCIe SATA HBAs, they're not very good. I'm trying not to use bad language. They are dreadful. There's a bunch of bugzillas linked at the bottom of this, but under high I/O, which can be just as simple as running the RAID set check, it will start producing DMA errors, and then suddenly drives are being booted from your RAID array. So early one Sunday morning, while it was performing the RAID set check, 2 drives got boosted from the array. Ouch. Solution, we changed the HBA, we looked at the RAID set, looked at its health. Now, we could go into recovery mode, but at this point, we were looking at trying to recover about 9 terabytes of data, 8 terabytes of data. It would take a while to do a full recovery. We'd have to work through this, but we looked in the detail of the RAID set using the MDADM tools, and it turns out one disk had a completely different event state than the others. 2 had the same event level, and 1 was only different by 1 number. So we actually did a force assemble, looked at the degraded array, checked the LVM metadata, checked the underlying file systems, virtual machine snapshots, all the data that was stored there, and it came up as consistent. We did a comparison later with a backup where it meant we were able to recover the environment in hours rather than taking best part of a day trying to do a full data set recovery. Going faster, how fast is your disk? Now, these are 2 of my favorite tools. Well, there's 3 tools here, but it's 2 tool sets. HD-PAR-T is my favorite sanity check. Be it it's a HD, an SSD, or a SAN-mounted piece of storage. It could be a flash device. It doesn't really matter. But just to sanity check that you're actually getting the IOPS you expect. I've seen cases with SAN mounts where we're fluctuating between hundreds of megabytes a second to tens of megabytes a second, which means that we've got an issue with the SAN fabric, or there's some issue around I/O allocation. In one particular case, we were consistently getting sub 10 megabytes a second off a tier 1 enterprise SAN. That's not good. That's not healthy, particularly when you're trying to run higher IOTP workloads or virtual machines off it. And it just happened that they set the wrong allocation for our workloads, and we were in the lowest performance tier. F3 read, F3 write are great for testing your flash storage devices and making sure that they actually behave as you expected, that they have the correct size that you expect them to, that they're not a dumb device where someone's faking the size and it's a 2 gigabyte disk pretending to be a 16 gigabyte disk. But they're also great for doing quick speed tests of how USB devices are behaving. Clusters. When you're dealing with HA storage requirements, usually people start talking about, I need a storage cluster for a particular need. There was a time not so long ago where I had considerably more hair and what little I had wasn't gray. First, understand the use cases and the RTOs, RPOs, what the performance requirements, latency requirements. Otherwise, things don't quite pan out as you expect. Again, I said earlier, RAID is not a backup mechanism. DR is not a backup mechanism. HA is not a backup mechanism. They're just simply methods for allowing for business continuity and high availability. But overall, you can't go and recover to an older version of a file. It's amazing the meetings I've been in where a customer said, oh yeah, we've got backup sorted because we do HA or we do DR to another site. And also fully understand the difference between active, passive, because that can really hurt you. And always remember a cluster of 2 is simply a problem waiting to happen. If you don't have a third quorum node, if you do not have an arbiter, which is becoming common for some software-defined storage technologies, you're going to get bitten at some point. So, HANFS. Have any of you implemented HANFS? Yeah, tried. Yes, good, right. Active is really hard and painful because you need an underlying cluster-aware file system to kind of do it properly. And if you use something like GFS2, which is one of the approaches, performance kind of falls off a cliff. Active-passive, you can actually do with shared storage over fiber channel, FCOE, iSCSI, or some other method. Don't do it over NFS. Don't try and do HENFS with an NFS backend. Life really is too short to try and attempt this thing, and I've seen someone do it. So what you do then is you make sure that a given partition that you're exporting is only active on one node. You use things like pacemaker to allow failover. You set up a VIP. Awesome. It kind of works. It will work. But understand your application workloads. So here we are. We've got an application service that's really latency sensitive. It has a sub 5 millisecond latency. Due to network issues, we would regularly see that exceeded. Regardless of how well the HENFS environment was working, we would exceed that 5 millisecond latency for a storage request. And the application service would fall over. So, fail. Also, if you're doing a managed NFS failover, because we're going to put node 1 into maintenance and do a managed failover because we're doing patching, you have to allow 30 seconds for things to cleanly fail over. Fail. Scaling, 2 nodes couldn't cope with the workload. We started with all the workloads on one node, and then we started with a mixed model where these mount points on node A would fail to node B and vice versa. You're now building interesting technical debt into your environment, and the customer at this particular occasion wasn't keen on automation. They preferred operational busy work because they didn't trust automated tools to manage some of this. And then we had to scale up to 3 nodes, which made things even more complex. So these workloads on node A would fail to B, these ones on B would fail to C, these ones on C would fail to A, and so forth, simply to deal with the growth. We did look at other technologies like Gluster, and the issue here was that the only protocol they would allow us to use was NFS, so we still hit some of the NFS issues. So it didn't actually provide the outcome that the client wanted, and the entire environment had to be virtualized. So we were running a highly available NFS cluster on top of a virtual infrastructure that wasn't actually highly available. And once you do this, you get no live migration, because in order for this to work, you have to turn live migration off on the instances. So we couldn't meet some of the customers' other SLAs, requirements, and objectives. DRB don't. I've just don't, okay? Because typically, maintenance is a nightmare. Failback, always test failback. Whenever you're doing anything like this, it's amazing how many projects I've seen going, we're all good, we've tested failover, but we've never, ever tested failback. Cluster 2, remember what I said earlier, is a problem waiting to happen. And Stoneth, you ever been in Stoneth hell where it's just cyclic? Like we went to do maintenance and we could never, ever get one node up without trying to kill the other. Yeah, been there, done that. Multiple single points of failure are what you often hit with these kind of projects. So understand the requirements and then look at the existing infrastructure, especially things like SAN arrays that you may be having to leverage because the environment's virtualized, associated network infrastructure. We had a project where we thought everything was nicely redundant and available, but actually everything went through the same core switch. And when we put a high I/O workload on it, it took down the core switch. And what is the real cost of the solution? Because otherwise these things just turn into crazy busy work and actually build up a very high project cost, whereas you might actually be better off going and strong-arming your traditional SAN vendor and having them provide a solution or capability. But often there's a statement that the existing storage infrastructure isn't reliable enough or doesn't meet those RTOs, RPOs, etc. But then they overlay this requirement, as I said earlier, this whole solution has to be virtualized, and the virtual infrastructure relies on the traditional SAN or on the existing network. But you can do some clever things to kind of abstract yourself away from that, like sticking some disks inside your hypervisors and then passing those through. But then you'll usually get someone in the organization saying, oh, no, but we have to live migration everything, and then you fall into yet another trap. To be honest, one of your greatest assets at this point is a really big whiteboard. Plan things out and then start putting little bit red marks through the things that are single points of failure for the customer. Or start looking at software-defined storage. Both Gluster and Ceph are widely supported open source projects. Gluster can run on virtual or bare metal. It's very, very simple to implement and supports CIFS, NFS, PNFS, and the Gluster Fuse driver. Ceph has a broader range of capabilities and can really do superscale. And I'm actually giving a talk tomorrow about the work we've done around Rook and Ceph for containerized management of Ceph and kind of the data operational side of Ceph. Now, what the FSCK? What else can we keep? Dust and humidity. We had a small machine room that got resized. We had to put in a storeroom. And they came in and they put in a new drywall and they covered the racks with dust sheets and they sanded everything and they took the dust sheets away. And we came in on Monday and we had to vacuum out every server. We had to wipe down the machine room. There was dust everywhere. And over the course of approximately 9 months, every single hard drive failed. Because plaster dust can get really fine, and it's amazing how far inside a disk it can get. Humidity. The aircon unit, separate location, leaked on a carpeted machine room. Yeah, these things do happen. And the temporary aircon unit couldn't cope with it. And in fact, I remember now there was a secondary impact, was the temporary aircon unit was wired to a plug that wasn't active at weekends because of some stupid timeout. So at the weekend, and the carpet wasn't entirely dry, the room turned into a giant sauna. So over approximately a 6-month period, we had to replace every goddamn hard drive. And in fact, I've heard reports subsequently, a number of the chassis started to rust out a year or two later. So dust and humidity are killers. Avoid them at all costs. So these days with IoT sensors, you can pretty much rig your data center to detect a lot of these things, all your little small, corporate sites that still have some equipment on premise. Highly recommend it. Expect the unexpected. This was a doozy. Corrupted LVM. So we had some enterprise systems consuming multiple LUNs off a SAN into a single volume group under LVM. The fiber channel, one of the fiber channel LUNs had actually been allocated to 2 systems by accident. There was no partition table present, so the team managing the other system assumed they had a nice clean disk and partitioned it and started using it. And it was great until our database fell over. Our primary tier 1 customer-facing database went. So because that particular LUN was in the middle of the volume group somewhere and was actually being used by a bunch of LVs. That's a really interesting one to diagnose what the hell went wrong. And in fact, we took out the other system when we tried to diagnose our problem. So recommendation personally is to always put a partition table on. I know some operations teams around here often don't do that when they're dealing with, scaling out volume groups because they just want to consume the whole disk. But as a protection mechanism, I always put a partition table on. Now, this was another great one. We were seeing a corrupted file system on a virtual machine. The XFS file system was showing regular consistency issues, and rebooting that particular VM was inconsistent. It would come up, it would be fine, it would run great, and then as part of trying to diagnose root cause of the problem, we'd reboot it, and things would get really weird again. And then we started to notice another virtual machine was having problems. This was getting really odd. Were we suffering a memory issue? Were we suffering a hardware failure? Maybe the CPU was going on the hypervisor. No, that virtual machine's on a different hypervisor. So it turns out there was poor LUN grouping again off the back-end storage. Virtual guests are hosted on KVM. There's a bunch of LUNs mapped into the hypervisor. But it turns out some of those LUNs have been also mapped into some guests. And due to the way LVM works, is we had a weird race condition because all the VGs had the same name, all the LVs had the same name. So we had /Linux VG /var /Linux VG /data. And occasionally, a couple of the systems would be cross-mounting each other's data and var partitions. at the same time. If you are building off templates in a virtual environment, I highly recommend you make sure you mount by UUID, and as part of your deployment process, make sure that it injects unique UUIDs when you do the provisioning. In this particular case, we went through a whole world of pain trying to diagnose the issue. I actually was able to spot it because I'd actually managed to cause it a few years earlier at home. It's amazing what you can do in your own lab and your own time and with your own degree of stupidity, but I've actually had this happen before. And I'm literally looking at the logs going, no, 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 not again. So yeah, expect the unexpected. So what next? Where are we going in this ecosystem? So they say everything, my clicker's not very happy, everything old is new again. So we all know we're always going to need more storage. And the fact is, simple fact is in the enterprise, hard drives aren't dead yet, right? Spinning rust still has its place and its price point. But you know, at some point, the TCO for flash will drop below that of spinning disk. And if you want to see an example of where that may happen sooner rather than later, look at EDSFF. This is a hyperdense flash storage platform. You can effectively put a petabyte of storage in 1U. So this is like a ruler format. It was originally called the ruler. It was an Intel format, and now there's a refined version that a bunch of vendors are adopting. This is PCIe interconnect on the end, but it's a ruler-shaped form factor. Really quite cool. And that's with today's storage densities. But these things are estimated to have an enterprise production life of 15 years if used correctly, versus having to replace spinning disks every 3 or 5 years. So your total cost of ownership suddenly starts to shift, particularly when you take power and cooling into consideration. If you've been to LCA before, you know we've had a lot of talks about things like persistent memory at the RAM level, and persistent memory type devices at the storage level. Things like Optane from Intel is a good example, where you can actually have memory that persists through a reboot. And then the cloud players are consistently innovating because they want us to spend more money, and I think our job in terms of the open source community is to out-innovate them and come up with more interesting ways for us to either perform analytics and use storage or find new use cases. But the one thing I'll leave you from is something when I was researching some of the futures around this, is a lot of the pundits say, no, this isn't dead, or rather, this isn't dead. It's still by far the most common enterprise backup medium, and whilst you may think you're backing up to the cloud, there's a very good chance your cloud somewhere is still backing up to tape. So tape ain't dead yet. So, thank you for your time. Hopefully I've given you some tips and tricks. Are there any questions? It's gone very quiet. And here we go.
Thanks for that. What do you use to back up at home?
Well, for my personal data, I use a cycle of very, very large USB 3 hard drives that I rotate through for large data, and then other data I'll also have an encrypted, and that's all encrypted, so I use Lux encryption on the hard drive, so if the hard drive ever gets stolen, they just see a partition saying this is Steve Ellis's hard drive, do not touch, and then the rest of the data is encrypted. Or I do encrypted copies out into certain public cloud resources. So multiple copies in multiple places, depending on the criticality of the information.
I've never heard of erasure coding before. This is a new thing. Could you spend 10 seconds on that? Or
Sorry, I didn't hear that.
Erasure coding? Sorry, I was a bit quiet there. You were talking about erasure coding for RAID replacement on steroids? I've never heard of this before.
Never heard of erasure coding? So that's a whole... So how many of you have never heard of erasure coding before? Okay. Erasure coding is incredibly popular in the software-defined ecosystem. I've dropped a whole deck just talking about that. There's some really good write-ups on sites like Storage Review. Wikipedia's article's reasonably good. The Ceph documentation has some really good references. But erasure coding is effectively a way to stripe data stripe data across multiple drives, designed specifically around recovery and failure set management. So I'll say I am happy to suffer a certain level of failure, which is your plus m or plus n or whatever you want to, however you want to factor it. So I'm happy to suffer a failure rate of 3. But the nice thing about erasure code is it's designed to work across systems. So when we deal with something like Ceph and we do erasure coding, we don't do RAID in an array and then erasure code. We erasure code at the disk level across the entire array. So you can actually just take out an entire, have a disk fail and replace it, or have a server fail and replace it, and the array will heal itself, and its heal performance is way above typical RAID technologies. It's usually much faster at healing and behaving. So it's quite nice and elegant, but it does allow for very elastic kind of +1 scaling, depending on the implementation. A lot of proprietary storage vendors have their own variants on erasure coding under the hood. Ooh, there's lots now. Sorry.
Hi, I'm Ben. I'm a FreeBSD user. I just wanted to ask, apart from licensing, what do you think of ZFS? You did see who I work for. I can't probably answer that. Linux wrote a really interesting piece about it recently. I'll defer to him. Right, okay. And I won't use BTRFS because I've already had too many experiments in losing my data.
Hello there. My name's Amy. Thank you for that really fascinating talk. I'm interested in something you mentioned earlier about data decay, and I was wondering, should data decay or should we store it forever?
There's a chap, Nat Torkington, who is ex-O'Reilly. He's based in New Zealand, and he gave a talk a number of years ago for the Privacy Commission, and he said, should there actually be a statute of limitations on your social media presence? You know, should there be a point in time where all your social media missteps expire naturally? Yes, it's really hard. An awful lot of data that we create today will live forever if the various cloud players have their way. But also, a critical thing often in the enterprise is secure data destruction. So there's some really cool tools around taking an existing storage device and truly deleting it, rewriting it to make sure that it's almost impossible to recover, even with intense digital forensic devices. So, and with things like GDPR and some other data restrictions around geography or credit card information or the uses of personal information, there's an awful lot of stuff going on around protecting data, hiding data, obfuscating data. Or another one is trying to make sure data is cleansed so that I was talking to someone who works at the UN, and one of their things is they want to provide cleansed data sets so that things are properly anonymized. So you can perform analysis without giving away too much about who the people are. And that's really important. Yeah? Look, I'm here for the rest of the week. I'm also giving a talk tomorrow in the Container Mini Conf about Ceph. So thanks for your time.